Okay, from Greensboro, North Carolina, we have Minerva Lithium. Presenting from Minerva Lithium, we have Sheba Dawood, co-founder and CEO, and Hermali Rathnaki, co-founder and CTO. Welcome them to the stage.
Today, the whole world is transitioning to clean energy, due to which the energy storage market is expected to increase in billions in coming years. Minerals are fundamental for clean energy transition. And earlier this year, in February, President Biden announced to bolster critical mineral supply chain for minerals such as lithium, which is expected to increase more than 4,000% in coming decade. Lithium is a primary component in battery, and battery market is expected to reach $183 billion by 2025, and this requires 1 million metric ton of lithium. There are various resources of lithium in the form of hard rock and brine. Mining lithium from hard rock is pretty much what you think it could be, very similar to traditional ore mining. On the other hand, brine are the natural resources of lithium, which are present in the form of salt lake, oceans, and continental brine, constituting 66% of total global lithium resources. So, solar evaporation is a current technique that is used to extract lithium from brine, in which water is pumped into large ponds, about 20,000 acres, and allowed to be evaporated for 36 months. And to just produce 1 metric ton of lithium, they use up 500,000 gallons of water, releasing 5,000 kilograms of carbon with a production cost of $6,000. What we see here, that we do have enough resources of lithium in brine, but lithium brine industry lack efficient direct lithium extraction technology to currently address exploding battery market. So addressing these challenges, Minerva Lithium have developed direct lithium extraction technology using nanotechnology. Our company was spinned off from my PhD project. During my PhD, I was able to develop nanomosaic absorbents, which are very similar to sponge. These sponge-like materials are chemically and physically designed to just attract lithium and reject all other minerals. So taking advantage of this selectivity, our process is two-step, which can extract lithium within 48 hours, processing it to battery-grade lithium. And to just produce 1 metric ton of lithium, we use 30,000 gallons of water with no carbon emission and production cost of $1,000. Let me show you the process. These are video. These are our nanomosaic absorbents, which are made at room temperature. And these are our filter units with filter that comes along with filter bag. In first step, we add nanomosaic absorbents. And in the second step, we add brine with lithium and other minerals. We allow it to soak for 24 hours, and later collect it to do ICP analysis, which helps to determine amount of lithium absorbed in the absorbents. ICP instrumentation helps to identify and measure the elements. So from our results, we have found out as the time increases from 0 to 24 hours, the efficiency increases from 40 to 95%. And later, we desorb and convert into battery-grade lithium. Let me show you our material physically. And let me show you our filter units that come along with filter bags and which can treat 171 gallons of water per minute. That is, it extracts almost 2 metric ton of lithium that is generating $42 million revenue per year. Our current customers are brine operators from lithium and petrochemical companies, and we are targeting to capture 1% of lithium market, which is expected to reach $13.5 billion by 2025. So comparing to traditional technologies and directly developed lithium extraction technologies, our technologies offer competitive advantage in terms of cost and efficiency. We are a team of scientists and engineers with former CTO of Halliburton serving as business advisor and former CEO of automotive industry serving as chief operating officer. I am Shiba Dawood, CEO and co-founder with a PhD in nanoscience. Himali Ratnaika is a co-founder and associate professor in nanoscience. Minerva Lithium, with its disruptive technology and outstanding team, aims to provide sustainable energy technology to rapidly growing energy storage market. And this technology is not just limited to lithium extraction, but can be extended to other critical mineral extraction like cobalt, nickel, with the water purification as byproduct. We are currently fundraising to move forward for the pilot demonstration. So if you are someone from clean tech space looking for investing, collaborating, please sign up for Minerva Lithium and join me in this journey to make United States a global leader in clean energy transition. Thank you.
You got a lot of smiles from these judges while you're pitching throughout the entire thing. Let's start with Rich.
First of all, congratulations on the progress. It's really critical national security need, obviously, in addition to the commercial innovation. To your 2x2 diagram that looked at the cost profile, so at scale, how will the cost profile of a kilogram or whatever volume or weight of lithium, how will it compare to the solar evaporation approach, please?
So solar evaporation and also comparing to our technique. So for solar evaporation, just to produce 1 metric ton of lithium, they spend $6,000, and our cost is about $1,000 to extract 1 metric ton of lithium.
Is there any downside? I mean, it seems like a dramatic improvement. Like, is there a logic? Is there a trade-off that's worth understanding?
Definitely. So we are eliminating the operational cost, and we are also eliminating a lot of chemical hazards and footprint and electricity. So these are some of the things that go into solar evaporation. Ours is room temperature technique. We do not use any forms of energy like electricity, and we have tried to reduce the water usage really low. That is, they use 500,000 gallons of water. We use 30,000 gallons, which is just 6% of it. So we have reduced all of these things, and that sums up the whole price.
Thank you.
Just congratulations and
Thank you.
Amazing progress. Is your value prop less water, lower cost, more lithium? Like as you as you look at those, like what is the core value prop of the company?
Our value proposition, I will put it this way: we are 500 times faster than solar evaporation, and we process battery-grade lithium. And those are some of the features that you mentioned that come along with that.
Thank you.
Like that. Mar?
Yeah, I mean, I think following on Rich's and David's, it's too good to be true. So now the question is,
Yes.
How big is the market? So I think you said you had 13 billion for the lithium market. How big is the mining market for lithium? Like, if you're going to sell these membranes and so on, and what type of sale is it? Is it, I just don't know any of these lithium brining mines, I guess. Are they, is it a bunch of little people, big people? Like, maybe you can talk about that.
Yeah. So right now, the market is 5.3, but it is expected to grow to 13.5 by 2025.
That's the tooling for mining.
Yes. And these are present in 2 resources. And brine, why exactly we are mentioning this? Because they constitute 66% of total global lithium resources. And we do have lithium there. So instead of going for the other techniques which are more carbon, which release more carbon emission, we do have naturally available resource just there. We just require a technology that can get it. And the current technique that is being used, like I said, like it sound, very ancient. You are using large ponds and really, highly and high operational and capital investment. So these are the direct lithium extraction technology that could actually bring a breakthrough here.
Sort of just quickly bringing the 3 of these questions. Why won't you be successful? What will cause your company to not be successful?
I would say that this company has various verticals. That's the reason we have said that we develop sustainable energy technologies. So, and this is not just extended to lithium, but other critical minerals, and like I mentioned, and also water purification. So this is a byproduct. You put a sponge, and when you remove the sponge, you also get water purified. So that could be one of the other vertical that we can extend. So
Just to clarify, you extract lithium from brine
Yes.
and produce battery-grade lithium and drinkable water?
yes.
I got to jump in.
Is that,
Yeah.
Just checking.
Also, yeah.
you go first.
How novel is that among your competitors? Does anybody else do that?
It's yeah, I can answer for that. It's our technology is the sorbent-based technology. There are much of the competitive technologies like nanomembrane, ion exchange. Ion exchange is the most competitive right now in the market and extracting lithium from brine. But there is a limitation in the ion exchange. Because the brine needs to be lithium rich, concentration higher 1,000 ppm parts per million. So our technology go all the way to the lower concentration, even the 50 ppm lithium concentration. That's where the uniqueness comes with our technology, because these sponges are nanomaterials. They are specifically tailored into get the lithium from the lower concentration. So one of the other advantage in our technology with compared to the ion exchange for lilac. And what they are doing is their ion exchange method is only for working for when you have more higher salt, TDS, it doesn't work. So they have to remove some TDS. And that's where our technology come in the two-column system. In the first column, we remove if we have a very higher concentration of TDS, like sodium chloride and all the dissolved solid, and you can remove those in the first column, and then with the impurities, the magnesium. Magnesium is the next one is coming with lithium pairing. So removing magnesium is really difficult, but in our materials, we will not going to have a magnesium in our material. That's why we can produce the high purity. These are research-based work, and we publish, and then these are fundamentally done in the lab work.
Jim?
I mean, is one of the downsides actually, you know, Richard mentioned the matter of national security, that this is so important that you're very limited in who can use this? And I noticed the Halliburton guy on your executive team. So is that, you know, a limitation here?
We don't see as a limitation, but actually because of his experience, and also right now companies like Halliburton and Schlumberger are also exploring these other avenues of lithium extraction, and he coming with so much of expertise and industrial experience more of, we find him much more suitable to the team.
So I'm going to copy one of David's earlier questions, which is when you think about 5 years from now, 10 years from now, what kind of a company do you have? Are you going to keep selling the technology to people who have brine farms? Are you going to actually just lease land or buy your own brine and sell lithium? What's the plan? Because it kind of sounds like a money machine.
It's actually, so we're looking for within 10 years is a big picture for the company. And it is not only that this technology is strictly restricted to the lithium. So we are also, this technology can apply for the critical minerals, other minerals, cobalt and lithium. And the big picture moving forward, and also we are giving the fresh water back. So we don't throw with the chemicals water into that. That is another avenue segment that we can go into. And also that other lithium producers and for mining. And so we are right now exploring and whether we can put our technology into the mining. So because this technology working in anything in that solution in the lithium, we can grab it. So we are working with actually right now we are in the discussion with Alabama, and then they do have in a Kings Mountain in North Carolina. And if you see the news that recently this morning, and they got $140 million from the DOE to mining for the Kings Mountain. And Kings Mountain has about 4,000 metric tons of lithiums, and you can provide within a year. So that's, we are also focusing on into that and with them, and we can expand that.
How difficult it is for you to reconfigure the system for other minerals? Just on a,
It is, right now, it is already, the lab scale work is done for cobalt and the nickel.
Okay.
And so that's why we are very promising we can go into the more of the critical minerals extractions. And also we're looking at the earth rare oxide metals.
Can I just understand, just from a technical perspective, is one of the materials pulling out the liquid as an absorbent, and then you're filtering, or through a
No, no.
specific, or? Sorry,
No,
thank you.
so it's you have the brine, right, with all the other impurities, other dissolved salt and the lithium. So what this sorbent do is sorbent absorbs selectively lithium into the sorbent.
Okay,
And
right.
then we desorb in the room temperature with the acidified water and take the brine, lithium-rich water out. And then we do the further processes to get to the lithium carbonate, battery-grade lithium carbonate.
Okay, got it. So you're extracting it in a liquid form, and then.
Exactly. So
isolate.
now when we do our customer discoveries, and so we found out some of the customers are really interested on getting the lithium-rich brine and without converting to lithium carbonate. So there also we do have actually right now the couple of customers that they wanted to have a lithium-rich as a lithium chloride or the lithium acetate, and then they can use that to produce the lithium metal. That is the another avenue. There's a big market we have in there with Tesla. Tesla batteries, they use in the lithium thin film metal. So this is one of the avenue, huge market that we can explore further.
You explained that so well. Thank you very
Thank
much.
you.
Give them a round
Well
of
done.
applause.
Good job.
Exactly.
I love like two female technical.
I feel like I know a lot about lithium now, and I knew nothing before.
Brine operators.
Okay.